note.
Okay, but do I put that in?
You put it right on top of the struct. So this, anytime you see this like hash brace thing,
Uh-huh.
uh, this is basically tagging something. So
Okay.
you can tag structs, or sometimes you can tag expressions in certain ways, or sometimes you can tag a module, um, stuff like that.
Okay. So now if I do that, okay, in this, okay. Ah.
So this is what I was talking about in my Python video about serializing stuff. Okay, like it's the same thing, just replace debug with serialize in the video. It's like, okay, the compiler would tell me that the struct is not debug because some of its fields are not debug. Yep, exactly.
Okay. All right, perfect. Remove this mutt.
Oh no, no, no.
Why? Because we're not doing anything to it other than just putting it somewhere.
Yeah, you're not mutating it. I think you got one too many spaces. Yep.
All right, perfect. Let mutt.
Yay.
Yay. All right, next one. All right, fields in this struct. Charge. Adam has a derived impl, but this is...
Oh, that is okay.
Oh, perfect.
Yeah, so that's just saying that you're not using it yet.
Oh, okay.
Which is a little silly. But there you go. That's what your molecule looks like.
That's beautiful.
It does look nice, right? You've got a sequence of atoms. They've got their own charges. They've got their own coordinates.
Yeah, that's nice.
Yeah.
Yeah. All right, well, there you go. That's that.
All right, why don't you go ahead and commit that? Because that was a lot more refactoring.
Yeah.
And now I think we're ready to make progress on the project.
All right, stage. CC. There we go. Introduced structs. And
oh, that's why oh god, I've had the little sidebar from Jitsi open the whole time.
Yeah.
That's probably that's why it looked so bad.
Oh no.
Sorry YouTube about the last hour.
That's oh wait, I don't need to save that. I just need to do Control C, unpushed. Perfect.
Perfect. Beautiful. All right. Vibe check. I guess we just did this, but how do you feel? It felt like a lot.
It was a lot. My brain is like freaking out a little just because it feels I guess this is a good time for YouTube to know that at this point, if it was just if it was just me, I would have given up learning a programming language by now.
No.
Yeah, I mean this is just so much, and like this project, like, you know, I don't have a reason to work on a project like this because in the research that we do, we already have stuff that does this for us. So like this is not a problem that I feel is necessary to solve. But but let me at least say this. I understand that in, you know, learning to program, you need a project. And this is a good project because it is directly related with what we're doing, to what we do. And so like I get the reason to want to do the project.
Wait, you picked the project?
Yeah, you're right. Yeah.
Honestly, okay, look. All right. I don't want to offend anybody, but honestly, this is not that good of a project. Like, you've basically learned, if we hadn't deliberately added structs there, you basically are done with the project besides some really painful indexing.
Yeah.
Right? Like, the rest of the project doesn't really have any programming per se.
Yeah. I guess Advent of Code probably would have been a better one to introduce.
I still think it's valuable to do this one because it'll give you some reps with for loops and stuff.
Yeah.
Like, we definitely need to at least compute bond lengths and do some of the geometry.
Yeah.
I'm not sure we need to go as far as like diagonalizing the moment of inertia tensor, because we're just gonna have. Although that gives us an excuse to add a crate, like that'll show us how to import a library, so we can turn it into a reasonable project. But strictly looking at the instructions, it's like there's I don't know.
Yeah.
I don't know.
No, I guess
see.
that's
I
fair.
definitely see what you mean. And the middle section is going to be a real slog, like computing all of this stuff.
Like this here.
But yeah, like the 3, 4, 5 are like basically the same. It's like bond lengths, angles. So we
Yeah.
maybe we'll skip some of it if it gets really boring.
Yeah.
But there's still some more that we can unpack here.
Yeah.
Is there anything else I can think of for a more, like a better project? Not really something self-contained like this, you know?
Yeah.
Because advent of code, most of the time you don't necessarily even need to make structs. So this is nice because I think it was useful to make a struct to organize our thoughts.
Yeah.
Let's compute some bond links. I think there's still some use here.
Okay.
Unless you're really bored. I guess I keep thinking, like, is it useful for teaching? And I'm not considering, is it just boring? Like, if you'd rather do something else, we can do something else.
I mean, I don't know. I think we can give it a shot. I mean, just giving bond links a shot, and if after that it's just like, oh god, this is so boring, we can move on to like advent of code, or we can.
Okay.
What isn't there? Didn't you used to have like this thing like what was it? There's some website that you could like get Euler's.
Yeah, Project Euler.
Yeah, Project Euler.
Or Euler, or
yeah,
like Euler or whatever. However you're supposed to say it, I don't know.
Yeah. Okay. Well, all right. Let's do that then. Cute. Okay. So. All right. So we've. Oh yeah. Hey, look. I forgot we already had this. Yeah. You remember this from like 3 hours ago?
It was actually, let's see, 1 hour ago.
It was only 1 hour ago. Oh,
yeah.
Oh man. No.
Well, we can tell that Zach's not having fun because time's not passing quickly for him.
Yeah, everything's going by real slow right now. Is this what time dilation feels like?
Yeah. This is actually a general, is it general or special relativity? I always forget.
Who knows, man? This is actually it's especially general.
Especially, okay.
All right. So
all right.
A function to create bond links. Okay. All right. Mastermind of structs. I'm assuming this is where I want to start looping over pieces of structs, right?
Sure.
Perfect. Well, okay, so the project wants me to do something with this. It says to calculate where x are Cartesian coordinates and I and j denote atomic indices. Okay, so for this little thing, I want to grab the x coordinate of the ith atomic indice. Okay. Is this where I need to start accessing my atoms vector?
Yeah.
Okay. So how do I loop over a struct?
So I think, yeah, that's okay. I think do you know, sorry, I'm being like pedantic in my head and I'm like trying to fight it internally. That's what this awkwardness is about. So I think what you actually want are two concepts that you looped into how to loop over a struct. So you can actually loop over a struct, but it involves doing something that we're not going to do yet.
Okay. Okay.
So the two concepts you need to know about are how do you loop over a vector and how do you access a field of a struct.
Okay.
Because this will let you access the vector in, I guess I need to hold it like this. This will let you access the vector inside of your molecule, and then you can loop over the vector.
Sure.
Yeah.
Okay, so
I guess all the pedant tree came out.
Okay, so how do I access a field of a struct?
With a dot.
Okay. with a dot. With a dot. Is it this? Okay.
Yeah, it looks a lot like method calls. So remember we do atoms.push.
Yes.
So you can actually now do mole.atoms. But that assumes that you have a variable called mole in scope.
Oh. So an mole?
Yeah, I mean you can call it whatever you want. So this is okay. All right. So remember, actually, this might be a new thing for us. How do you pass a value into a function?
Pass a value into a well, you have to give the function the thing, right?
Yeah. So yeah, if you scroll down just a little so we can see main.
Oh, let.
Yeah. So well, no. Remember that you called loadgeom inside of main.
Yes.
Okay. So you have your molecule inside of main. If you want to compute the bond length in a different function, such as bond length, you're going to need that molecule inside the function.
Uh-huh.
So you're either going to need to write the code that you're writing right now inside of main, or you're going to need to get mole from main inside of this function.
Get mole from main. Okay.
So how do you... Well, okay, where are you going to call bond length? Let's answer that first.
Well, I mean, I guess for at least for the purpose of this project, I would call bond length inside of main.
Okay.
So that means I would have to define mole in main.
Well, you already have mole defined in main. But the mole that you define in main is not going to be accessible inside the body of bond length.
Okay.
Let's just write some code. So move your debug mole into bond length. This is good. We've been talking too much today, which I think is part of the problem. I need to stop talking and just like get you compiling code.
Okay.
Delete your for, delete everything. Don't delete everything. Just yeah, delete that, and try to run it.
Okay. Not found in scope. Okay.
Now the other thing you might want to do is if you're going to call bond length in main, just go ahead and put the call inside of main, where you want to call it.
Okay. Do I call it like I've called load geom here?
Yeah.
Well, okay. Let mole. No, wait, that's not what I wanted, right?
Right. So let is for creating variables, and the reason that you did let on load geom is because it was returning things that you wanted to assign to variables.
I see.
As you've written it, bond length doesn't return anything, so you wouldn't actually need to capture anything from it. So you don't need to use let.
So I would just do oh my lord.
Yeah, you could just say bin.
I would just do that?
Yeah.
Okay. Perfect.
Okay. So what are you thinking right now?
Well, I'm thinking I need to get mole to be something that I can utilize.
Yep. Okay. I guess we haven't done this. So if you have something and you want to use it inside of another function, you do what's called pass it as an argument.
Okay.
So the way that would look inside of main is that you will put mole inside of the parentheses with bond length.
Like that.
Yes.
Oh, okay, that makes sense.
However, yeah, if you run that, we'll get some new errors.
Unexpected argument of type molecule. Remove the extra argument.
Which is not what you want to do. What you actually want to do is the opposite of that, is tell bond length to expect that argument.
Oh, shit.
And...
redo... Oh.
Yeah. Wow, it's taking this long to do this. All right, go to your init file real quick. I knew about this, but we never actually fixed it. Go up to evil mode. And in the config section of evil mode.
Yeah.
I think the function is called evil set undo system.
Okay, so... Oh, How do I do the thing? Is it an open paren here?
Yeah, that's fine.
Okay.
I'm pretty sure it's evil.
Yeah, that's what it said. Undo.
Well, yeah, but I think you have to say evil set undo system or something like that. You should enable company mode real quick, and it'll help us out.
How do I
enable? So meta X company mode.
Oh. Company mode. Oh wait, where'd it go?
Yeah, you might have to type some more. And then backspace a bit. Yeah, evil. I'm pretty sure it's evil set. Dash undo.
All right.
Yeah. Okay. And then set that to quote undo dash redo.
Undo dash.
Single quote. Sorry.
Oh, sorry. Undo dash redo.
Yeah.
Okay.
And then make sure to eval the whole evil block. So yeah, close that paren and then eval the evil use package.
Okay.
Okay. Now go back and try to redo, but it might not work until... Oh, it did work. Okay, good. So undo redo is the built-in Emacs.
Yeah.
I actually use undo tree, which is like something else we'd have to install. So undo redo is the native version.
Okay.
Okay. Now back to Rust.
We have to tell it to expect molecule.
Yeah.
Is this like is it just like expect dot?
Oh, sorry. I shouldn't have said expect because yeah, expect is a completely different thing. I just meant that you have to update the signature of bond length to show that it takes an argument. So it says this function takes 0 arguments, but 1 argument was supplied. So you've supplied an argument.
Yes.
But you need to update the function to take an argument.
Okay.
And the way you do that is, again, you say variable name, :type. In the function signature where your cursor is.
Variable name, :type. Okay, I see. So, just mole.
So if you want it to, if you want it to be called mole, and it's going to be a molecule, then you just write that.
Yeah.
It takes one, I'll take 1 mole, please, of type molecule.
So cool. All right, so that
there you go. So
okay.
now you're using mole. Yeah, let's take note of this. You're using mole inside of a function.
Using
big
mole.
Steps.
Oh man. Okay, now we're using mole inside of our bond length function. And
yep.
So now you said that in order to access the field, I need to do...
yeah, give that a try inside of your debug.
Oh, I see. Wasn't it... What did you say? It was mole dot something?
There you go. Company's helping you out.
Uh-oh.
Yeah, give that a run. It looks pretty similar, but without the molecule on the outside. Right, now it's just printing the vector.
This here? Oh, yeah.
Right?
Oh, yeah. Okay.
Now, let's keep playing with debug a little bit.
Okay.
Why don't you print one of the atoms? Whichever one you want.
Okay, the first one.
That's usually a good choice.
All right, data moved here.
Oh, geez. Okay, I didn't actually think about this.
Move occurs because TMP has type atom, which does not implement the copy trait. Consider borrowing here. Oh, okay. Okay, I'll borrow. How about I borrow? How about I ask for them? We're like, actually, can I... Excuse me, sir, may I have another?
Yep.
All right. Hey, look at that. Okay.
Now, let's chain our field accesses. Why don't you print one of the fields of an atom?
I don't know how to do that.
Wait, company did. Go back. Put the dot.
Put the dot. Wow!
See, the little brick is a field.
Dude, that is so cool. Oh, dude, that's so cool.
Okay, so let's keep that,
Okay.
and now proceed. keep that as our template, so we can refer to it.
Okay. So now proceed with doing some bond lengthy stuff.
Yeah.
I don't want. Okay.